Welcome to our lesson on scientific notation, our last section of this chapter. So scientific notation is defined as a product of a number greater than or equal to 1, but less than 10, and an integral power of 10. So for example, this is written in scientific notation because we have the product of a number, and this number is greater than or equal to 1 and less than 10, and it's multiplied by a power of 10. This, however, is not in scientific notation because this number right here is not between 1 and 10. So again, your scientific notation must always be one in which the number that's being multiplied by the power of 10 has to be between 1 and 10. Less than 10 can be also equal to 1. Let's go over some basic powers of 10 just to make sure that you have your computations correct. So here we have some basic powers of 10 that I want you to write down into your notes. So 10 to the power of 0 is equal to 1. 10 to the power of negative 1 is equal to 1/10. And the reason why that is because 10 to the negative 1 power is the same as 1 over 10. And 1 over 10 is just 1/10. Thus, the decimal 1/10. And in your notes, it says that if n is positive, meaning if the exponent is positive, then the decimal moves to the right. If n is negative, if the exponent is negative, the decimal moves to the left. Now let's just get into some practice problems with scientific notation. Please write the following number in practice problem number 1. Go ahead and write this number in scientific notation. Pause the video and play it once you have your answer down. Hopefully your answer came out to the following. 6 4/10 or 6.4 times 10 to the 13th power. Okay, for practice problem number 2, now let's start off with a decimal instead. Go ahead and write this decimal in scientific notation. And you should have written down 8.9 times 10 to the negative 11th power. And the reason why it's negative 11 is because when you write this number back in its decimal form, you would have to move the decimal 11 times to the left, 1, 2, 3, and so on, to get to the original decimal number. So when you have a decimal number and you want to write it in scientific notation, if it's a small decimal number, then you're going to have a negative exponent to write it in scientific notation. But if you have a decimal number that is greater than 1, then you're going to have a positive exponent for your power of 10 when you want to rewrite it as a number in scientific notation. Okay, now let's go backwards and we're going to start off with a number in scientific notation, and now you're going to write it in decimal form. So for example, this is practice problem number 3. Go ahead and write this in its decimal form. Pause the video. And you should have gotten the following number, 0.000000783. And you want to just double check to make sure that you've moved your decimal correctly. So I'm just going to count 1, 2, 3, 4, 5, 6, 7 to double check that I did move it 7 times. Okay, for practice problem number 4, you will submit your answer into the form. And for practice problem number 4, please write this scientific notation in decimal form. Go ahead and write that down and complete the answer onto the form. Alright, moving right along, let's now get into simplifying expressions that involve scientific notation. So here we have our first example. So to simplify this expression, what you want to do is separate your numbers and your powers of 10 and divide those separately. So first thing you want to do is divide 9.3 by 3, and that will just equal 9.3 divided by 3. Oops. That equals 3.1. Now you're also going to divide out your powers of 10. So 10 to the 12th divided by 10 to the 4th is the same thing as 10 to the 8th. So when I simplify my expression, 3.1 times 10 to the 8th is my final answer. And it's useful to use scientific notation when you divide with really large numbers, because then you don't have to deal with all those zeros at the end. So again, when you're dividing with scientific notation or numbers in scientific notation, you can divide the numbers separately and divide the powers separately. And then you just want to double check to make sure that your quotient of that first set of numbers is between 1 and 10. All right, so now we're ready for practice problem number 6, and this one you are going to complete on your own and submit your answer onto the form. So for practice problem number 6, please simplify this expression. Take a moment to write that down. And once again, because in the commutative property you can multiply in any order, you can multiply the numbers separately from the powers of 10. And double check that your answer is between, or your first number is between 1 and 10. So for our last practice problems, let's now get into expanded notation. So for example, let's say we have the number 48,307. Now to write this in expanded notation, we're first going to rewrite each digit in its actual value. So this is really 40,000 plus 8,000 plus 300 plus 0, yes, you include the 0, plus 7. Now here you want to rewrite this in scientific notation for each of those numbers. So we're going to have 4 times 10 to the 4th plus 8 times 10 to the 3rd plus 3 times 10 to the 2nd plus 0 times 10 to the 1st plus 7 by itself. Sorry, plus 7 times 10 to the 0 power. So with a single digit like 7, you still want to multiply by a power of 10 to make sure that you've included all the numbers. Now I know it might seem irrelevant to include that, but from what I've seen in the book, you at least want to include still the zeros to make sure that you've included all the powers that are in the problem. So now for practice problem number 8, I want you to rewrite this number in expanded notation. You are allowed in your notes to go from this step to this step. So you don't need to include that middle step if you don't feel like. And I want you to rewrite this number, 64.91, using expanded notation, and make sure you're using powers of 10. Go ahead and submit your answer onto the form, and if you have any questions, please bring those questions to class. And as for our random picture, as you see in the upper right-hand corner, I have a picture of a muscular arm with a football, because this Sunday, the San Francisco 49ers are going to take on the Ravens, and they will win. And the random note that I want you to include into the form is that the bone located on the pinky side of our forearm is called the ulna. Okay, if you have any questions, I'll see you tomorrow. Bye-bye.